Hello my dear students, welcome back to Bright Learning app. Now we are in the last part of the first chapter, some basic concepts of chemistry. Okay, already we discussed a lot of the important concepts in chemistry. So the last topic is reaction in solution. You know, most of the chemical reactions that we are doing in laboratory will be in aqueous solution. Okay, in the laboratory we are doing most of the reaction in aqueous solution state. So in order to represent the concentration of solution, we will use some terms. Okay, where we are doing most of the reaction in laboratory means we must know how much of the solute or how much of the substance can be dissolved in the solution or in the solvent. Okay, so otherwise the concentration of that solution we must know. Okay, then only we can design a good reaction with a good yield of product. Okay, so how can we represent the concentration of solution or the amount of substance present or dissolved in the solution or in the solvent? For that purpose we have four terms. More than four terms are there. In this chapter we are discussing four terms. First one is mass percent. Mass percent is the first term we have to use to represent the concentration of the solution. Or weight percent. Instead of mass percent we can use weight percent. Okay, this is the first term we can use to represent concentration, and the second one is very simple, that is mole fraction. Second one is very simple, that is mole fraction. Another important term we have to use to represent what concentration of a solution. And the third term is molarity. And the fourth one is molality. Okay, molarity we will represent using capital letter M. Molality can be represented by using small letter a. Okay, so dear students, these are the four important concentration terms we have to represent the concentration of a solution. Okay, so you can expect one more question from this area. Okay, so we want to learn in detail which this form means. Okay, so the first one is mass percent. Okay, to calculate the concentration of solution in terms of mass percent, we have an equation. From that we have to understand that mass percent is equal to mass percent is equal to mass of solute. Already you know solution is nothing but solute plus solvent, isn't it? If you are taking a solution, at least two components will be there, which is the lowest component, that is called the solute, and the component which have in excess amount, that is called solvent. Okay, suppose we are taking a beaker. We are taking water up to this level. We are taking water. Okay, and we are adding some amount of salt to this water, and we are completely stirring the salt. So what will happen? That salt will dissolve in that water, and we will get what? Salt solution. Okay, so let me ask a simple question, which is the solute and solvent present in the salt solution. No doubt the excess amount is water, so water will be solvent, and salt is the little amount, that will be solute, isn't it? So if you are taking a solution, there will be at least two components. One will be solute and the second one will be solvent. Okay, then we will get a solution. So to represent the concentration of that solution in mass percent, we have an equation. Mass percent is equal to mass of solute. Suppose you want to get the concentration of the solution in mass percent, we have to get the mass of salt in the solution divided by mass of solution, or we can write total mass of solution. Total mass of solution means mass of solute plus mass of solvent. Okay, into into 100. This is the equation. This is the equation we are using. This is the equation we are using to represent the concentration of a solution in terms of mass percent. Okay, so this is one more question. You must by heart this equation. Very simple equation. Mass percent is equal to mass of solute divided by mass of solution into 100. Have clear? Very simple idea. Suppose let's do a simple question. Let's take 18 gram of water. Let's take 18 gram of water. I'm taking 18 gram. Sorry. Only 18 gram, not 180, 18 gram of water. Okay, I'm taking 18 gram of water, and to this water or to this solvent I'm adding 2 gram of a substance. This is a solvent, as you know, water here acting as solvent, and to this solvent I'm adding 2 gram of a substance. Okay, which is the substance? A substance. For a we can take the name A. Okay, to this 18 gram of water we are adding some amount of a substance called A, which is 2 gram. Okay, I want to get the mass percent of the solution. How we will get? You know, here 18 gram of water is here, so that will be solvent in excess amount. 2 gram, little amount, that will be solute. Okay, 2 gram of A is the solute in the solution. So how we will get the mass percent? Mass percent is equal to mass of solute. Mass of solute means 2 gram, and divide by mass of solution. Total mass of solution means solute plus solvent. So mass of solute is 2 gram, and mass of solvent is 18 gram. So 2 gram plus 18 gram. Okay, so we will get and we should multiply with 100. We should multiply with 100. So 2 into 100, 200. 200 divided by 2 plus 18, that is 20. 200 divided by 20, we will get 10%. We will get 10%. So we can say that when we are dissolving 2 gram of any substance in 18 gram of water, we will get a solution having the concentration in mass percent 10%. Have you clear this? Very similar. Likewise, you can expect one more question to find the mass percent. The equation is very important. If you know this equation, we have to substitute the values. We will get the answer. A mass of solute divided by mass of solution into 100. Mass of solute divided by mass of solution into 100. This is the idea. Have you clear? Yes. So dear students, let us move to the next concentration term, that is mole fraction. That is mole fraction. Very simple idea. Let's take a solution. As you know, if you are taking a solution means, there will be at least 2 components. First one is solute, the second one is solvent. Okay, solute is I'm taking solute is A and solvent is B. Suppose solute is A and solvent is B. Anyway, you have to take that. And what will be the mole fraction of A? Mole fraction of A is equal. Before that, dear students, solute is A and solvent is B. Okay, fine. And I'm writing Na represents number of moles of A, and NB represents number of moles of B. Okay, A is the solute present in the solution, B is the solvent present in the solution, and Na is the number of moles of solute in that solution, NB is the number of moles of solvent in the solution. Have it clear? Yes. And we want to get mole fraction. We want to get the mole fraction. Mole fraction of solute. Let us take the mole fraction of solute. So mole fraction of A. Mole fraction of A is equal to, very simple, number of moles of A. Number of moles of A divided by total number of moles. Total number of moles means number of moles of solute plus number of moles of solvent. So number of moles of A plus number of moles of B. So this is the equation we can use to find the mole fraction. So mole fraction of a component is equal to number of moles of that component divided by total number of moles. Have you clear? Suppose if you want to get the mole fraction of B, mole fraction of B. What will be the equation, dear students? Very simple. Mole fraction of B is equal to number of moles of B, okay, divided by total number of moles. So Na plus Nb. So clear? So this is the equation we can use to find the mole fraction. Very simple. And one more thing you have to remember here. That means this is a symbol called chi used to represent mole fraction. Okay, suppose you are adding the mole fraction of A plus mole fraction of B. That means two components present in a binary solution. So if you are adding the mole fraction of all components in a solution, that will be equal to 1. That will be equal to 1. Have it clear? Yes. So these are the points we have to remember here. So mole fraction is a concentration term. We have to represent the concentration of a solution, and that is nothing but mole fraction of a component means number of moles of component divided by total number of moles. Have it clear? Very simple idea. And dear students, so the third one is molarity. Another important concentration term we have to remember. What is molarity? Molarity means number of moles of solute. Number of moles of solute dissolved in 1 liter of solution. That is called molarity. Molarity can be represented by using capital letter M. I'm repeating, dear students, definition is very important. We can expect that one more question. Okay, molarity is the number of moles of solute that is dissolved in 1 liter of solution. Okay, so what will be the equation for number of moles? What will be the equation of molarity? Molarity is equal to number of moles of solute. What is the equation? Number of moles of solute. Number of moles of solute divided by, what is the definition? Number of moles of solute dissolved in or present in 1 liter of solution. What is liter? Liter is a unit of volume, isn't it? So number of moles of solute divided by volume of solution. Volume of solution. Unit is very important. Volume of solution in liter. This is the equation we can use to find the molarity. Okay, molarity is equal to number of moles of solute divided by volume of solution in liter. Okay, so number of moles of solute divided by volume of solution in liter. Unit is not here, is very important. Okay, so the point is very important. Number of moles of solute dissolved in 1 liter of solution, that is called molarity. Okay, here number of moles of solute. How can we calculate number of moles of solute? Number of moles of solute is equal to given mass of solute. Given mass of solute divided by molecular mass of solute. Okay, given mass we will represent generally W solute, and molecular mass can be represented by capital M solute. Okay, so number of moles is nothing but given mass divided by molecular mass. We already learned 4 equations. You remember that? Given mass divided by gram molecular mass, given mass divided by gram atomic mass, given volume divided by 22.4 or 20.47, given mass given number divided by Avogadro number. Do you remember? You have to recall that, isn't it? So number of moles of solute is equal to a given mass of solute divided by molecular mass of solute. So we will get the answer by substituting the values here. Okay, let's do a question. Suppose I am adding 4 gram of NaOH. 4 gram of NaOH. 4 gram of NaOH. This is a question. Okay, I am adding 4 gram of NaOH. NaOH is nothing but sodium hydroxide. To which solvent I am adding 250 milliliter of water. 250 milliliter of water. Okay, I am adding 4 gram of NaOH to 250 milliliter of water. No doubt here NaOH is solute and water is solvent, and I will get a solution. What will be the molarity of that solution? Molarity is equal to what? Number of moles of solute. Number of moles of solute divided by what? Volume of solution in liter. This is the equation. isn't it? So dear students, number of moles of solute, here the solute is NaOH, sodium hydroxide. Okay, so number of moles of solute, how can we calculate number of moles? Given mass divided by molecular mass. What is given mass? That is 4 gram. So 4 gram divided by, okay, molecular mass. Here you know sodium hydroxide, sodium having atomic mass 23, oxygen is 16, hydrogen is 1. So here we are getting 0, here 1. So 40 is the molecular mass of NaOH. So 4 gram divided by 40 gram. 4 gram divided by 40 gram divided by volume of solution in liter. Okay, so what is the volume? That is 250. Okay, this 250 is not in liter, this is milliliter. According to the definition, number of moles of solute dissolved in 1 liter of solution. The volume of solution must be in liter. So how can we convert this milliliter to liter? Just divided with 1000. So what we will get? Very simple. When 4 divided by 40, we will get 0.1 mole. 0.1 mole we will get, and divided by 250 divided by 1000, we will get 0.250 liter we will get, isn't it? So when we divide 0.1 mole divided by 0.250 liter, we will get 0.4 mole per liter. 0.4 mole per liter, and which is equal to 0.4 molarity. 0.4 molarity. Have it clear, students? This is called 0.4 molarity. So when we are dissolving 4 gram of sodium hydroxide to 250 milliliter of water, we will get a solution having the concentration or the molarity of 0.4 molar. 0.4 molar. Molar means molarity. Have it clear? So this is the idea we have to remember. This idea we have to remember in the case of molarity. Molarity. And the next term, dear students, that is molality. Next term is molality. What is molality? Molality and molarity have just a difference. Here we will use small letter m to represent molality. Molality is the number of moles of solute that is dissolved in 1 kilogram of solvent. 1 kilogram of solvent, not solution, solvent. In the case of molarity, number of moles of solute is dissolved in 1 liter of solution. Liter and solution. But in the case of molality, we are dissolving number of moles of solute in 1 kilogram of solvent. 1 kilogram of solvent, not solution. Here it is solvent, not liter, it is kilogram. Okay, so what will be the equation? Molality is equal to number of moles of solute. Number of moles of solute divided by number of moles of solute dissolved in 1 kilogram. What is kilogram? Kilogram is mass. So mass of what? Mass of solution? No, mass of solvent. Mass of solvent in kilogram. That's the idea, in kilogram. So unit is very important. In molarity, that is in volume of solution liter. In molality, mass of solvent in kilogram. The numerator is same in both cases, number of moles of solute, but denominator is different. What is the denominator? Number of volume of solution in liter in the case of molarity, mass of solvent in kilogram, that is the case of molality. Okay, so dear students, very important. Have it clear? So this is the 4 concentration term we have to use to represent the concentration of solutions. Okay, most of the reactions we are carried out in the laboratory will be in solution phase, so we can use this concentration term to represent the concentration of that solutions. Have it clear, dear students? So 4 concentration term, one is mass percent, second one is mole fraction, third one is molarity, then molality. What is mass percent? Mass of solute divided by total mass of solution into 100. What is mole fraction? Mole fraction of a component is equal to number of moles of that component divided by total number of moles. And what is molarity? Number of moles of solute dissolved in 1 liter of solution. What's the equation? Number of moles of solute divided by volume of solution in liter. And what is molality? Number of moles of solute dissolved in 1 kilogram of solvent. What's the equation? Number of moles of solute divided by mass of solvent in kilogram. Have it clear, dear students? So the chapter is over. So go through this chapter. This is the first chapter of our 11th standard. Here we are only discussing the basic ideas that we need to move forward. Okay, without knowing this we cannot move forward, and all the information that learned in this chapter is needed in the coming all chapters in the 11th and 12th and all the coming years. If you are going with science in your future, in your higher studies, this is needy. Okay, without this we cannot do anything. So by understanding the importance of this chapter, clearly watch the video and go through the NCERT textbook and also do the maximum number of questions, and practice and make the thorough the important concept. Okay, all the very best.